Okay. Why do I have fewer buttons? Ugh. Hold on a second, John. Why? I don't want the light clad. We'll start in just a moment.
Good morning.
Good morning, John.
Good morning.
Yeah, that one. Well, I can tell you if you're on the other side of the wall, it's also very loud. Okay. I'm desperately looking around for the last set of slides that are not here quite yet. All right. So good morning and welcome to the Jose Working Group meeting at IETF 124. I am, but it's not very loud. The guy came and tested it, but hello? Is that okay? I have to be really close. All right. So welcome to the Jose meeting at IETF 124. We have a pretty full agenda, so let's go ahead and get started. First of all, this is the note well for the IETF. These are the rules and procedures by which we operate. You have agreed to these when you registered for the meeting, and all participation in the IETF is bound by this set of rules. If you have any questions, feel free to ask myself or Deb, our area director, sitting in the far corner of the room. These are the meeting tips. By now, you've probably seen this several times this week, but do remember to put yourself in the queue and go to the microphone. And with that, this is our agenda for the day. Is there any agenda bashing? Oh, I did forget one thing. I do desperately need minute takers. I asked on the mailing list. I didn't get any volunteers, but we actually, with a heavy sigh, we have a volunteer who is deeply appreciated. Also, for everybody who presents or goes to the microphone, we had some questions about the minutes being inaccurate last time. So it's really your responsibility to make sure that it's a community effort here to make sure the minutes reflect what you thought actually happened. So with that, Tiro, are you online? don't see him. Okay, there you go. You ready? Yeah, we can't hear you at the moment. Are you speaking or?
Does my audio work? Can you hear me?
Wow, your audio is quite loud.
Sorry. Yeah, I was just checking whether it works.
Yeah, so Tiru. All right. Tiro, I know that it's really late where you are, so I know you wanted to go first. Yeah, can you, your audio's not working. Can you leave and come back? Looks like he's using the light client. Okay, is he coming back? All right. So I see you back. Okay, now you're coming.
Can you hear me now?
Yes.
Okay. Yeah, thanks. Sorry, there was some issue from my
Ask who to talk quieter.
Yeah. I'll give an update on PQC camps for Jose and Jose and the changes that we have done from the last IETF meeting. I'm not able to move the slides.
Tiro, unfortunately, your audio is very very bad.
Can you hear me now?
We can hear you, but now it's breaking up.
Is it any better?
Yes.
Okay. Could you move to the next slide, please? Yeah. So far we have addressed all the comments received from the working group. The only pending issue is whether to use AKP or OKP or a new key type. There's been a lot of discussion in the working group regarding which key type to use, and there was no agreement so far. So what I'm trying to do in the next few slides is to list all the three possible options so that we can try to get some consensus. Next slide, please. Okay, the draft currently uses AKP. The AKP key type is already defined in for the PQC signatures algorithm, which is dilithium. It requires the ALG parameter. All right. So if AKP is used with KEP, it introduces a challenge that the same key cannot be used in both the direct key agreement and KEM with key wrapping modes. This restriction does not exist for traditional asymmetric algorithms which have been using OKP. There's been disagreement on whether this is an advantage or this is a disadvantage, and that's where I think there's a lot of back and forth mail has been exchanged in the working group on whether this restrictive mode, which restricts the mode by providing the ALG, is a good security option or whether it's too restrictive. Next slide, please. If AKP is used with HP key, especially with post-quantum and traditional hybrid schemes, it poses some other interesting challenges. For instance, if you look at the example of the two algorithms where it's the same PQT hybrid scheme, but the A8 algorithms are different, then if AKP is used, then it would require different keys for each A8, which adds which adds to the complexity as well. So AKP is not just a problem with multiple modes as well, but even if you're using different A8 modes, you would have to use separate keys as well. Next slide, please. Yeah. So I was just trying to go through all the before the meeting, go through all the email threads and the reasons why some of the working group members really wanted to go with AKP. One of the arguments has been that NIST, as per the NIST guidance, each key should be used only for a single purpose and one algorithm during the security lifetime, and it aligns with the NIST guidance. But I believe this concept does not apply here, since the same key pair is only used within Jose Jose, and they are just two different modes of the same algorithm. And the draft already ensures two different algorithm identifiers for direct key agreement and key encryption with with key wrapping. And different context strings are used for key derivation in this case, so that derived keys from KEM and KEM plus key wrapping can no longer collide. So I don't know whether it seems like the guidance does not hold here, but I think we should definitely discuss whether this guidance will play any role in deciding whether AKP should be used or not. Next slide, please. Yeah. So the other one was OKP. OKP. This is the way the prior versions of the draft had used, where the curve was carrying the PQC chem. But the semantic confusion would be the use of curve looks odd for PQC chems, and it does not have any provision for providing the ALG parameter, though RC 80307 states that it does not assume there is an underlying elliptic curve. And in the last meeting as well, there was several working members opposing the use of OKP. Next slide, please. Yeah. So what I did in the last few weeks is, right, I mean, since the arguments were never ending just for discussion, I raised a pull request to define a new key type chem. Basically, it introduces new parameters, which is chem param, which carries the PQC chem algorithm, and ALG is made optional. So for if someone wants a restrictive policy, then ALG would be mandated. If someone wants the flexibility, then ALG can be removed, and chem parameters becomes redundant when ALG is present. So the optional ALG preserves flexibility. Next slide, please. Yeah, so I think now that we have three options, we seek input from the working group on the key tab that we want to use. Chem, which is now going to be newly defined, which is going to be purpose built for PQC Chem, and it will have all the flexibility of either using AKP or excluding it. AKP is secure, there's no doubt about it, but it's too restrictive. That's the argument that I've been seeing in the working group from several members from the working group. OKP seems to be the least preferred option, though it's flexible, but it's confusing to use for PQC. So I've seen several differing technical opinions on using OKP, AKP for PQC integration. So I was thinking, if you go ahead with ChemTag, right, I think deployments which want to mandate ALG can go with that, and deployments which want this flexibility, like what OKP was offering, could exclude ALG. This seemed like an way forward, right, to address the address and get consensus within the working group on progressing this issue, which is stalled this draft for quite some time. Next slide. Yeah, I think this is the only issue that needs to be discussed and further addressed. So I would like to hear comments on this and how the chairs would suggest that we resolve and make progress on this draft.
All right, Philip.
Thank you. I don't know if this is due to the audio quality, but could you possibly go back to slides 3 and 4? That's 3. That is to me very clear. The algorithm is required in order to fulfill the requirements of AKP, and then every single key or every single JSON web key needs to have a particular algorithm, which in this case already says whether this is a direct key agreement or CHEM with key wrapping. We talked about this on the list. I'm not going to repeat all those same arguments, but can we please go to slide number 4? And this could be because of the audio. I didn't quite understand. How is this, or is this any different than the same problem or quote unquote problem as on slide 3, in that it just makes the alg required? I don't know if there's anything specific to post-quantum traditional HPKE that you're trying to point out here, or whether this is just the same thing as on slide 3.
Yeah, if you look at that slide, right, it's not specific to the modes in which JSON is used, right? This is specific to because it's a fully specified algorithm. You with PQT HPKE, you not only specify the asymmetric key pair, but you also specify the aid algorithm that you would have to use. So, for instance, if you see in this example, the traditional part is H25599 with MLCAM 768. For both the algorithms, the only difference is the aid algorithm, right, which could be Chacha or this PCM, right? So just because the aid algorithm now differs, would have to have two different keywords now.
How would, like, if this was represented as a chem type, then the algorithm would be the same minus the AEAD at the end?
Yeah, if you specify it as a chem new type, right? I mean, you could skip the ALG parameter itself. I mean, the ALG would be the PQC chem would be the chem parameters would be the X2259 and MLCAM 768. Just the asymmetric key pair part of it.
Yeah, so what I don't understand is, if this is not specified, then how does the recipient know which AED is used for this particular HPKE mode? Which is why I'm asking. This seems to be the exact same argument as on slide number 3.
Okay, I see your point there. Yeah. But for the JWK representation is, I don't think the aid algorithm is required, right?
All right, go ahead, Brian.
I'm having trouble hearing. Tiru. I don't think I'm alone, but I'm going to try to sort of interject what I think the argument here is, which is exactly the same as the previous slide, except that in the context of HPKE, the AEAD as well as the KDF are part of the algorithm identifier. So it's the same problem. It's just, it looks worse if you think about it as a problem. If you think of it as a benefit, it's sort of good, but it's just taking the bit a little bit more. And there is admittedly some weirdness, I think, to having an AEAD tied directly to a public key portion of the key, but it's not any different than the previous. Well, it is. It's just a different kind of manifestation of the previous problem. But also, these algorithm identifiers are not like, they wouldn't actually look like this in HPKE for Jose, because you've deliberately chosen shorter algorithm identifiers. So it's also maybe a little bit of a misleading example, although conceptually it is.
No, I'm not referring to the long names. It could be the shorter names, but the challenge is, if you have 4 different AID algorithms, you would end up using 4 different representations of the keys.
Right. Yes, exactly. Which is exactly the same thing as the prior one.
Yeah, the prior one is just basically 2. This would be as many number of AID algorithms that would be supported with that asymmetric key pair.
All right, let's hear from Hannes, and then Tiro, I don't know if you can send an email summarizing all of this, but we're having a really hard time understanding you.
I hope you can hear me.
You're good.
Okay. Yeah. So I think it would be interesting, instead of throwing different solutions around, it would be good to figure out what are the desirable properties we actually want to have. Because, like, from my angle, I wouldn't want to use or carry the algorithm identifier in a message in the first place, because that was a discussion we had a while ago. If you do that, you allow an attacker to modify this algorithm identifier, and then all sorts of bad things can happen. What you should instead do is you have a key ID in there, and then the recipient needs to figure out, like, what's the policy associated with that key, and he needs to look it up, because you will in any case have to, if you have a proper implementation, double check whether a specific key is allowed to be used with a specific combination of algorithms, cryptographic algorithms. And so I think this is sort of like, we try to come up with all sorts of fancy ways to convey the algorithm identifiers, and they all have pros and cons for different reasons, because we haven't clearly articulated what the requirements are. But then all of this is sort of useless, because if we have the string we see in front of us, if I have a key somewhere in my library, in my configuration, it needs to say key XYZ is only allowed to be used with those parameters, with those algorithms done. So I think this is there's a number of problems in that discussion around these algorithms. I don't know where the excitement comes from to have so many different views, but I think it's we at some point in time we took the wrong turn here with these algorithms, and we get obsessed about its semantics.
All right. We're going to need to move on. So can we move this discussion to the mailing list? And Tiro, I don't know if you noticed the notes in the from the note taker, but if you could supplement the notes, that would be useful.
Sure, I'll do that. Thank you.
All right, so next up is the JSON web proof stuff. Mike? JSON web proofs. Confirm my selection. Do you want the clicker? Or do you?
Good morning. I'm Mike Jones, and I believe my colleague David Waite, aka DW, is also online with us. I will be doing half of this presentation, and then DW will take over. So we've made 2 sets of document updates since Madrid. A number of editorial improvements, and the main focus of 11, which was published a little bit ago before the cutoff, was using consistent terminology about headers. So that's been done. Then we got feedback from IANA. IANA is doing a useful thing, which is providing early feedback on drafts before publication is even requested. So we did the things that IANA suggested we do in 12. Those of you who were in COSE yesterday saw me present about an update to the BLS key representation draft. And in particular, while I'm not going to recap it all here, we had been using uncompressed XY coordinates for the BLS keys, but it was pointed out to us by the esteemed John Bradley and others, DW as well, and Emil Lundberg in Sweden at Yubico, that In fact, implementations don't use XY for the most part. That it's already well established in the industry that they're using a fairly bespoke compressed key format called Zcash, where the 2 top bits are assigned special meanings, but it's used in some ledgers and other things. Furthermore, John pointed out to us that, in fact, the BBS signature draft, which Tobias Looker and a colleague of his are authors of, use the Zcash point representation internally in the BBS signature computations. So every implementation is already going to have support for that representation. So while I'm usually in favor of things being consistent, I gave up and said, okay, we'll be consistent with what engineers are already doing. So Emil and I and DW changed the Jose and Jose BBS point representation. DW was kind enough to update JWP's examples to do the same. And that's what we have done to the specification. This isn't on this slide, but I'm going to extemporaneously talk to it. It was talked about in CFRG a whole 2 days ago. There's this whole pile of dependencies for BBS finishing. JWP is at the top of that stack of dependencies. Then you go down and there's BBS signatures. Dan Benet has agreed to let John Bradley progress BLS signatures. There's also the pairing-friendly curves draft in the CFRG, which, like BLS signatures, had been dormant for 2.5 years. But Yumi Sakumi, I probably got the last name slightly wrong, the lead author on pairing-friendly curves, did say that she's resurrecting it and is looking for collaborators to finish that. John had suggested to the CFRG chairs that we have a BBS interim to try to unblock progress on this whole cluster of dependent documents, because there are real people and real deployments that want to use this, among other things, for uncorrelatable age attestations. So watch the CFRG space. We're kind of dependent upon all of that progressing to finish here. We did update the CBOR examples, both to have them and to match the current representations. The goal is to have a set of semantically similar JSON and CBOR examples. Right now that's a work in progress, but DW is a master of automation, so I expect that will come true. Mike O is at the microphone.
Mike Ownsworth. This is a for my understanding question. You said you're at the top of this stack of stuff, which has pairing from the bottom. Are you actually at the top, or are there other things that consume
stuff using JWP would be further up the stack? In terms of the stuff I'm touching that I'm trying to finish, it's at the top. But you know, Leif Johansson is in the room. He could talk about stuff further up the stack that wants to use BBS and ZKPs. Should he choose? Good point. We've made registry changes, as I said, because Ayana suggested that we do. Oh, here comes Leif. Oh, no, he's not speaking. He's just checking in. You're such a good man. Oh, now Leif is in the queue. He's eligible to speak.
So we had to your point, we had a side meeting yesterday to talk a little bit about like what are And are there any engineering challenges associated with getting CKP mechanisms to production? Now, I'm channeling John here. So this, you imagine
That's
the beard.
scary,
and
scary.
the beard.
I'm imagining.
Right? Imagining John saying, he would say something along the lines of, like, if you look at things like Longfellow, who was designed to be like deployable in the sense that it doesn't require changes to existing issuers. There is so much complexity in Longfellow that people have expressed concern whether you can even like in reasonable time have a good security proof for it, right? To have confidence that it actually does what you think it does. And a lot of that complexity comes from the fact that Longfellow has to deal with MDoc and the format. The format that we've designed, or that, well, not we, but the MDoc designers produced to be a good engineering solution for those use cases, actually turned out to generate complexity at another end. So the question is, right, is there a way to shift that complexity a little bit, make it so that the issuers have to adopt to other formats that are better suited to CKP processing? That is an open question. I don't have an answer, right? But that was the purpose of the side meeting discussion, and well, could also be something we want to discuss at other sort of side meetings. But the feedback from SEC dispatch on Monday was pretty clear that the IETF seems to be interested in the topic, at least. Yeah.
I'm going to take the prerogative as being at the microphone to give a little background on what Longfellow is. It is a zero-knowledge proof scheme developed by Google, but put into publication so anybody can inspect and re-implement it, using traditional curves, in particular the NIST P256 curve rather than the BLS curves. And it operates on an unmodified MDoc data format in CBOR, and then can make statements about that. Imagine doing that. Well, you can read a paper and you can find code that does do that at, as Leif said, some complexity cost. Stefan Santason is at the front of the queue.
I just want to fill in this discussion because we looked at this very problem together with people from Google, and we came to the conclusion that you could make it very much simpler with Longfellow with STJOT if you don't use any of the features of STJOT.
If you don't use any what?
Any of the features of STJOT. If you just include all the information in clear text and let CKP handle the disclosure, then you can make it a lot simpler.
Thank you. Who's next in the queue?
John.
John Matson.
Yeah, thanks. I will try to read the peering friendly curve and review that to speed things up. But talking about deployments of this, is there any data that is like too late? Now a lot of people are trying to migrate away from elliptic curves to PQC. What's the plan for these kind of credentials? Will they not migrate to PQC, or is still this a step and you will eventually move to lattice-based? And do you have a plan for that?
So, sorry, Stefan, you were before me. It looks like, oh, sorry. Okay. Okay. So, so John, I'm not 100% sure. It's complex. I mean, first of all, if you look at a lot of the CKP mechanisms, they have perfect forward, like VBS, for instance, has perfect forward privacy, right? Which means that you cannot unblind stuff, even if a quantum computer like breaks the underlying elliptic curve key, but you can then forge new attestations with the same subject. I think that's true, but it is probably the case that all of these mechanisms will have to find post-quantum alternatives. The problem is that research is still being done on that. There's no clear front runner, right? We are at a place with post-quantum for CKP where we should have been like 10 years ago, like, in order to make the deadlines in a reasonable way. So we're kind of screwed anyway, right? So I think the question is very relevant. Right? How much shelf life does this stuff have? And I think there's such a the problem is that there is a there are the way the EUDI wallet wants to do selective disclosure for many countries depends on doing lots of signatures in the cloud. And if you do the numbers on that, it is starting to look like that won't actually be possible, scalable. We're talking about like buying so many HSMs that it's going to be a problem, right? So a way around that is to deploy ZKP, because it allows you to achieve the unlinkability targets without having to do batch issuance and like one-time use credentials. So I think we're kind of pressed. I think we're going to wind up in a place where we have to deploy ZKP for performance reasons, not necessarily
for performance.
For performance reasons, not necessarily for privacy reasons. So yeah, you're forced to deploy something with a shelf life of maybe 5 years, right? And then hope that the researchers come up with a post-quantum like replacement that is with a reasonable transition mechanism. This is like flying upside down. Yes.
But from my point of view, and I think John Bradley and others, we just need to finish the BBS stuff and have that stable point. I know John was joking that Dan Benet considers it established cryptography, which mathematically it is, but standards-wise it's not. So we need to do our jobs. There's an area director at the mic.
No, there's John.
John Bradley.
Hi, Deb. So of course I largely agree with Leif, because we are in fact the same person, done with mirrors. There's a lot of pressure for both privacy and performance reasons to implement at least some of these solutions in EUID wallets. There's also additional questions around when you have cloud HSMs. There are subliminal channels in some of the traditional cryptography that's being used, which may be used to leak information if the government who's running the cloud HSM might not be entirely trustable, etc. So there are a number of different things. There's work being done on post-quantum threshold signatures and such. I believe NIST has a competition coming up. There's a conference theoretically next week, which I guess might not happen due to the government shutdown. So there is a lot of work happening. We probably need to finish off the stuff that we have while some of the post-quantum stuff comes along. A lot of us think that probably these zero knowledge mechanisms need to be used to get the most bang for the buck. We may have to use them in combination with each other. There's no reason why you couldn't possibly use BBS for selective disclosure and use ZK snarks or a version of Longfellow for doing the holder binding, and potentially the predicate-based proofs. No one zero knowledge system has it all. I will probably be proven wrong in the long term on that, but at the moment, it doesn't look like it. Now, I know that there are people who have serious doubts about pairing-based cryptography. We need to finish the specs. If there are, in fact, good reasons why this approach shouldn't be used, we need to actually surface those as opposed to just using them in practice and potentially ignoring some people's disquiet. But I have yet to be given a concrete reason for that disquiet. So let's see the process play out. And yeah, I'm being disruptive and attempting to, rather than just complaining about the CFRG, I'm attempting to motivate stuff through there by participating in the process and grabbing various authors by the ear.
All right.
So while I have learned a lot about this by being your AD, I am without my hat at the moment. So I do think the process here and in other working groups within the IETF, this is a progression to get better and better protocols to do identity management of whatever sort, right? Disclosure, selective disclosure,
Yes.
whatever, right? So we're on a progression, right? And I think you need to continue down the progression. I think you need to not let perfect be the enemy of the good. I do think you need to, if by working on these things that are perhaps older technologies give you knowledge for the future technologies, I think you move that way. I think you don't want to leave yourself exposed by waiting for the next best thing, zero knowledge proofs, whatever. Leave yourself exposed in the meantime. So I do think you need to, I do think there's value in working on something that may not live forever,
but
and that includes in the zero knowledge proof space using things like elliptic curves and SHA-2, right? I mean, there's nothing wrong with SHA-2, but the elliptic curves, like you'll learn through that, and then you can migrate that or use that knowledge to move to post-quantum. So I do think this is you have to look at this as a progression, not as this is the final answer.
yeah, absolutely.
Okay, but that's just me. That's me as a person, not as your AD.
And
maybe it is me.
I'm now going to uninterrupt my own presentation. We've had a valuable ecosystem discussion, but there's a few points about JWP specifically, which my co-author DW is now going to speak to, and then we will wrap up post haste.
Excellent. Can everyone hear me?
We can,
Yes.
DW.
Excellent. Can you go back one slide real quick? I just want to speak a little bit more to this. So as part of creating better CBOR examples, we had one for, I believe, BBS, but it was more of the messages, and there's part of the process like encoding the keys that we just didn't do. We internally already had a key, so we just used it. We discovered an issue that even though we define our own header registry and we define an algorithm, and that algorithm needs to point to our own table of algorithms, that we don't have that benefit for JWK and CWK. If you restrict to an algorithm, it's from the existing JBS, JBE, and COSE registries. So we're evaluating right now what the impact is of dropping our registry and pointing to those. So that's some work ongoing. We didn't get that done in time for -12. We'll see what that looks like, see if that causes confusion, having those algorithms in. I know that COSE does have like hash algorithms and other things in it, but you can imagine that the JSON web signature and encryption algorithms registry doesn't have a lot of those today. So this is a point that we're actively working on. Next slide, please. This is another point. So we got some implementer feedback, which is absolutely great.
Yep.
And a point that we had been pushing off for a while is this idea of having subclaims. So JSON proof tokens is the analogy of JOTs or CWTs. Since we have multiple payloads, we map those to individual claims. And so if you want to release like a family name, that would map to payload slot 2, for instance, in your issued credential. And so this is more of a building block for applications, but it kind of fills in the same, or is meant to target the same problem domains as something like SDJOT and SDCWT. Next slide, please. So the approaches of these are different. So for those familiar with SDJOT, it works a bit like a preprocessor. So you remove sections of the document and replace them with cryptographic hashes. And then as you disclose things, the preprocessor will go and replace those with the actual content or remove the hashes if there is none. So you get a subset document out of the process. With GPT, like I was alluding to, it's more of a key value pair system. And we rely on the underlying algorithm to be to take efficiencies with understanding that, since algorithms like BBS kind of inherently understand the multi-message concept. But the difference here, or I should say that these have different trade-offs. Our goal isn't to try to make everything able to be expressed the same way, but we don't want to limit the ability for people to solve the domain problems they have with GPT if they're able to solve those with SDJOT. Next slide. So we had feedback over the last 3 weeks from 2 people who had implemented prototypes. And the feedback, again, it's something we kind of understood, is that mapping payloads to entire claims was just too limiting. So a great example is an address claim. You might not want to give someone's real address. You might instead only need to share that they have an address in a certain country, or that they have a certain postal code. A full list of affiliations or nationalities. You may not need all that. There may be additional information as these become more structured. And
DW, interruption, we're over time now because I let us digress. So bring us home.
Okay, next slide. So today, because we don't have this, the only options that people really have will be to create new claims to describe this subset, which isn't really ideal. This isn't a problem that SDJOT has. Next slide. So the proposal is to actually make a way to describe that a payload holds a subset of a claim. We have a couple of different requirements here. We want this to be useful for JSON and CBOR. We want to make it so that people aren't concerned about remote processing of data. If someone's using these expressions, they don't worry that there's going to be a security issue, that there's going to be computational or memory gotchas for evaluating these. Ideally aligns with work already in IETF. And even better would be if some of the application domains like digital credentials are already using something similar. Next slide. Oh, why didn't any of the checkboxes show up? Next slide. This is karaoke. Anyway, the evaluating these, there's a new work called CBOR Pointer that just hit as implementer draft in CBOR, I think 2 weeks ago. It actually winds up lining up pretty well with what is being used in the SDJOT VC metadata, which itself is very similar to what is being used by OpenID for VP for their DECL queries. And so what we were currently proposing is very similar to CBOR Pointer, with a few features kind of taken out for simplicity. And very similar to those, if you limit it down to JSON, to DECL and SDJOT, removing what this query syntax they have, where you can do an array expansion to compare against anything in the array, because we're not doing queries. Next slide. Quick example, document. Next slide. So this would be how it would be expressed in GPT today with the big address. Next slide. So we add basically this expression syntax to be able to say that we have just this piece of information that comes from within a claim. Next slide. So our questions, we're still trying to get feedback. This kind of aligns with what people have done in prototypes, but does this seem like the proper approach? Also, how important is it to reference something defined elsewhere versus kind of creating our own derivative? As I kind of allude to, there's a couple of different pieces of work that we're based on. And then one other piece from an implementer was they liked the idea of being able to decompose and recompose documents completely, similar to what the W3C verifiable credential group did with data integrity and RDF.
DDoP wrap up.
So we're kind of evaluating how important that would be. Okay.
And I'll say it's not on the slides. There's one pull request. It contains this proposal. DW, if you could put the pull request on the list, that would be perfect.
Okay.
And I blew up our time budget. Apologies.
All right. So I think that we take the open questions to the mailing list as well. Thank you both. I want to take it back and stop slides and start the new slides. All right.
All right, Mike Jones again, representing a different set of co-authors for a different draft. We've all been working on the Jose HPKE for a bit in concert with the parallel work on the Jose HPKE spec. We listened to people on the feedback they gave at IETF 123, and we've tried to incorporate the suggestions made. One was by adding the recipient structure, which I'll discuss in a moment in more detail. We're now referencing the 2B HPKE draft rather than the existing one. We removed some stuff that doesn't make sense. We added an algorithm for Matt Chanda at Apple, and we corrected a few other things. Those are all published. So among other things, Sophie from Google had recommended that we change the way we use some of the HPKE parameters, in particular the info and AAD parameters. That advice was given both to the Jose and to the Jose HPKE representations, and that was done in parallel to both. So info, rather than being the thing that's magically populated, became a recipient structure, whereas AAD is now magically populated if you want to. Oops, that's backwards. So the recipient structure went through a couple iterations, as it should. Thank you for the feedback. I hate canonicalization too. I don't know how that ever got in. It's because I wasn't paying enough attention. So now the recipient structure is representable without any canonicalization. It has some constant text. It has some separators, which are hexFF. It has the content encryption algorithm, i.e. the ENC parameter, and it lets you provide some additional information if you want. What this does is it binds the content encryption algorithm into the HPKE computation itself and enables you to bind other information into the computation as well. And again, this is totally parallel with the changes which were done in Jose, which were presented yesterday by Hannes. We added another algorithm suite, or algorithm point, and you can read what it is. You can read it in the draft. This corresponds to what Apple's actually doing in practice. we thought, okay, they're doing it in practice. That's enough reason to give them a code point to specify it. If people don't like this, you can do what you do and raise issues on the list or in GitHub, but this was added. So that takes us up through when we'd published. I had made a promise to do what Richard Barnes had asked us to do in his last call draft, with some support from others at IETF 123, to make it 100% unambiguous how the addition of the HPKE modes affects JSON web encryption. Previously, that had been done kind of piecemeal. In fact, in the published draft, it is still done piecemeal. There's a set of things which were stated to be true of the two HPKE modes, and then some kind of piecemeal, I'll use the word again, text saying, well, then you apply these steps out of the encryption instructions in JWE, and you apply these steps out of the decryption instructions in JWE, but you don't do the rest. And that was kind of messy. People were correct in saying that was messy. So I thought, you know, Richard wanted to clearly integrate the two new key establishment modes into JWE. I promised to do that. Life overtook me. I did not get it done until last night. Apologies. But there is now a pull request that does exactly that. The nature of that pull request is that the core of 7516 JWE is two sets of instructions. The encryption instructions are 23 points long. I pulled those instructions verbatim, both encryption and decryption, into the HPKE draft now. In fact, I first did so unmodified in commit 1. Unmodified other than I translated XML to Markdown, but I believe faithfully. And then commit 2 integrates the additional instructions for the two HPKE key establishment modes into the general instructions for JWE. As Brian had requested, and I thought we did last time and we blew it, the draft now clearly updates 7516. So there's several sections that are explicitly going to be replaced. That's the core of what this PR does. And quite to my surprise, once I really buckled down and did it over the last 3 days, it did very little. It was much simpler than I thought it would be. It was far less invasive. Almost all the steps still apply. There's a couple conditionals in a few cases, so that in particular, so the integrated encryption works. But I believe that this PR will satisfy the primary requests that came out of 123, which is make it unambiguous what the relationship is between Jose HPKE and JSON Web Encryption itself. So you're all requested to review that. I will get to next steps, but the esteemed Mike Unsworth is loitering at the microphone. Please unloiter yourself.
Sir. Mike Unsworth. So I've just, again, a personal interest question. Hopefully I don't derail this one too. Given that I'm somewhat of a tourist here, one of the things that's, how do I structure this? HPKey is a one-shot API, right? I get public key, I send crypto and content, boom.
Yes.
One of the things that's always been great about Jose and Jose is that I can encrypt the bulk once and then do multiple recipients. Have you broken that? Are you still supporting the multiple recipient mode? Are we moving to HPKE entirely? Which I haven't been here. So what's going on?
Okay, very good clarifying question. There are two modes in which HPKE is used in this draft. One is integrated encryption, the one shot. That can only be used with a single recipient. That's clearly stated in the draft. There is also a mode where HPKE is used to encrypt the content encryption key. That can be used with multiple recipients. And in fact, the examples are indicative of that. The example we gave for integrated encryption is using the compact serialization, which only supports a single recipient. The example we gave for HPKA key encryption has multiple recipients. And indeed, you can mix that, and the draft explicitly says this. You can do key encryption for one recipient, which with HPKA key encryption, you could do it another way for another recipient. It's mix and match like it always was. So it fits very well. Does that answer your inquiry? Thumbs up. Thank you. So this is my last slide. As I see it, the primary next steps for the draft at this point are A, confer with all of y'all, using my best Southern lingo in Montreal, to determine whether the mitigations and responses to the feedback we received are the right ones, or if not, to iterate. Karen had asked me privately if maybe we want to have a side meeting. I would love to do that. I'll need help with the logistics of making that happen, but I would love to do that. Brian, apologies to you and Philip that we did not get together. In the interim, we didn't get together. It's my fault because I didn't get this PR done, which was the thing which I thought would be the concrete basis of us discussing and collaborating. So my bad. Let's do that here. Thank you. Please review the PR. A bunch of people that were already interested in it, including Joseph, have explicitly been asked to review. Reviews are coming in. That's perfect. Then I believe we will be in shape for a second working group last call. I'll note just as a coordination point that as chair of COSE and my co-chair Evo determined that COSE HPKE is ready for the second working group last call decision on the list. I am done.
All right, thank you. Brian? Yes. Stop slides. Share slides.
It's tight.
Yeah. Oh, sorry.
Hasn't get- I can't see better though. That's part of the problem. Okay, so I wanted to take an opportunity to provide my perspective again on Jose and HPK. I gave some pretty impassioned feedback at 123 that I don't think was heard, or at least not acted upon. And I guess I'm here again to try to reiterate that, despite, sorry, I'm a little thrown off. I'm just trying to improve the work here for the working group content of the draft, and some things were said recently on the list that kind of throw me off. I'm trying to wrap my head around that, but try not to dwell on that. There's a long history here, trying to get something out here that worked. Jumping to Madrid, though, I stood up in front of the working group and made an impassioned plea to try to improve a few things in Jose HPK. Tried to provide a little bit of context in the sense that I've been working on Jose both from basically the very beginning, both in the standards world and in implementation that's used in very, very large production systems throughout the world. And I've seen both the good and bad, and therefore have some personal feeling of investment of it currently, as well as wanting to avoid very embarrassing or costly potential problems in the future, which there is some history of having in this working group. And it would be great if we could take a little bit of effort to try to avoid those going forward. And I had a picture of a golf ball here to try to say that I know we've all worked, or many of us have worked in this working group world and SDOs for a long time, and there's often disagreements. There's often difficulty coordinating. I've been on both sides of feedback from a document, feeling like there was feedback that was not wanted or not wanting to be heard, as well as trying to provide it. But I believe that I have for some time been giving very, very reasonable, rational, reasoned feedback in the area of this document that has gone completely unacknowledged or surface level acknowledged and just sort of brushed aside. Apologies, I do have some frustration about all this. So one thing that happened in Madrid is I asked if we could do better, and I listed out a number of ways that I thought were paths towards that, as well as an offer to help. There's a lot of things that could be improved here, but really what I was trying to do is make a plea for some improvements with respect to the treatment of alg and ink in the HPKE Jose document. During that meeting, okay, Hannes would like to.
Go ahead, Hannes.
Yeah, so I wonder, so like Brian, I know your presentation style for quite a while already. It's a very long sort of slideshow on pictures and history, and I wonder, I think it would be good to get to the point, because there's no point in whining about things when it's often happens that you don't necessarily get in a group what precisely you want. And sometimes it's also a question of, like, we had this discussion in GitHub, where it's sometimes hard to figure out what your specific proposal is. And I'm wondering whether this is like your last slide, your previous slide showed, you offer to help. You want to be the co-author of some other document. That's great, but I'm not sure this is the right approach.
All right, for today, let's move on through this presentation quickly, get to the end, and focus on what our next steps are.
Yeah, okay. So I offered to help work with the authors of the document to try to improve things. Several of the authors were in the room and acknowledged that, in fact, they would reach out to work on that help, and that never happened. I don't know. I'm not actually sure what you're talking about, Hannes, but thank you. Here's some history. A lot of things happened. None of them were directed at the feedback that I participated in at 123. I did want to point out that there are some real world downstream SDOs and things that could really, really make use of a stable, quality document in this area. And because that's not in place right now, they are contemplating doing things that are, in the very narrow context of what they're trying to accomplish, reasonable, but very, very fracturing. And I find that to be very concerning and disappointing, because I would like to see this work meet those needs on a reasonable time frame. Really, where I was trying to go with this here and previously is that the current structure and treatment of alg and ink in the current document completely violates the baseline constraints in JWE. It just does. Read the text. I don't know how else to say it. I know we've tried to ignore it, but that doesn't change the baseline text.
Let's
Several of the designated experts, other than the one that would have to recuse themselves from the document, actually agree with this. And just adding a required algorithm in the registry that is effectively null encryption and explaining that you can do that because it says you can do that, is not actually meaningful. This was the slide that I presented previously. I do think if we don't do better, it would be extremely unfortunate. There are a couple of other options that I realize that there's not the appetite to consider here. But again, actually updating RFC 7516, both in the tooling and the actual document content, in a way that it becomes clear that ink is no longer necessary or relevant in the integrated encryption mode. And also making the key encryption algorithms, I called monomorphic here. It's not a real word, but right now they have variant behavior, which is very, very contrary to what we've been trying to do, both in the base document and fully specified algorithms. Anyway, the proposal I'm making to move forward is to update RFC 7516 such that HPKE JWA integrated encryption does not use ink at all. You need to update the document. You're already updating the document. I don't understand why we couldn't just get rid of the awkward and dangerous construct. There seems to be a lot of attachment to it, but that's there. And make the HPKE JWE key encryption distinct algorithms. Bike shed your favorite syntax here.
Okay, before we move to the queue, as Mike had mentioned, and I didn't get a chance to ask you ahead of time, I think maybe a side meeting to get everybody physically in the same room to discuss some of these things might be helpful.
That probably would be helpful. Yeah.
Okay, so I will work on coordinating that. So assuming that we are going to have that type of a discussion sometime the rest of this week, at this point we're moving to the queue. I don't want to talk about history, and I don't want to talk about opinions. I just want to talk about technical ways forward. So with that, the queue is open. Hannes?
Yeah, thank you, Karen. Technical things. This slide, the document currently says it updates RFC 7516. That is one legitimate way to update the semantics of some new functionality. If you go to the previous slide, or the slide which has the experts, asking the expert currently before the document is done, of course it's not in line because we are adding new functionality and the experts will have to take that into account, that what we are specifying here. So like I think the issue is blown out of proportion because this is a small piece of the whole document, namely the key type on, like, back to the discussion we had at the beginning of the meeting when Dero made his presentation on the algorithm. It's a very similar issue. For some reason, there's a lot of excitement on what values you put into this, into these parameters. And we forget that the actual content is really with the values of what HPKE we put into. I think we tend to dismiss this a little bit too quickly, and like we are battling the wrong battle, I think. The important stuff in the document is the HPKE part. We are just basically saying, here's the algorithm, and that's it. So it looks like a gigantic challenge, but I think it isn't. I think we are very close to a resolution here, and the slides don't do that justice.
Hanna, I didn't understand what your opinion. Could you live with the changes suggested by Brian? Like
So-
you also talked a lot about history and feelings.
Yeah, there's a lot of history, but so I think what this is asking for, Brian wants to literally update, if I understand this correctly, literally update the RC 7516. The approach we took was you can, in a new RC, you can basically say it updates the RC 7516 on that specific issue. You don't need to rewrite the whole original RC. I think it's the same issue, but it's just a different way of doing it mechanically. Does that make sense to you, John?
I don't know, but let's move forward in the queue.
Philip.
Thank you. Brian, before that, do you want to respond in any way?
I'm not sure. I don't think that addresses any of what I've been trying to say, so it's hard to respond.
Okay. So I wanna follow up on a side meeting on the PR that Mike mentioned. There's already discussion ongoing, and independently of these slides, a very similar feedback on asking to drop the enc entirely from the protected or unprotected header when HPK integrated encryption is used was requested or suggested. I did have a look at the PR myself. I did do early reviews, and I also looked at this from the designated expert point of view. The delta between the PR and what Brian is suggesting is not big. It's fairly, I'm suggesting it is a fairly simple, small change that we can explore in the side meeting and come to a conclusion, hopefully.
Okay. Mike, did you still want to be in the queue very concisely? Quickly.
Mike Jones. The reason that we'd retained the use of enc with a designated value to indicate integrated encryption is there's plenty of code out there, as well as some instructions in Jose that date back a dozen years, saying that a way to distinguish between a JSON Web Signature object and a JSON Web Encryption object is you decode the headers, and if ENC is present, it's encryption. That's the invariant that the authors were trying to maintain by keeping the use of ENC. I'm not saying that's decided.
Okay.
I'm trying to provide rationale for why the draft is the way it is. The other thing I'll say is the reason the authors didn't change any of that is we attempted a consensus call on what to change it to in Madrid, and it was inconclusive. It being inconclusive, we didn't change it. Thank you.
All right, Deb.
Okay, so this time clearly with my AD hat on. So a couple of things. One, we're not calling it a side meeting. We're going to call it a design team.
Oh, sorry, design team meeting.
Yeah. So these process things are key, right?
Yes.
So I have access to a room if we can find a time. And if the room is available, another problem, for you to bash it out, also has a ping pong table in it. So maybe you can duke it out that way. So that's that. The second point I was going to make is an update to a document, to a specification is not a BIS, right? So you're not changing, you're not replacing all of it, you're updating it. And you can update selectively. That's
Absolutely. Yeah.
Easy peasy lemon squeezy, right? That's exactly what an update is. There's fair bit of churn about what's an update and how you document it and what do you do, whatever. But I mean, updates are possible, and that's what it sounds like you need to do here. You're not BISing the document, you're only updating the
Yeah,
document.
I think that's
Okay,
that's
right?
established.
So I do think you need to sit down face to face and decide what you're going to do here, because it sounds like he's got reasons why he doesn't want to use Enc. You've got reasons why you might want to use Enc. Just like decide. And you may need to be creative, right? So for the reasons you don't want to use Enc and the reasons you do want to use Enc, maybe there's, I don't know, but you may need to be creative. So
Certainly.
put your creative hats on and let's get it done. Okay. So
Yeah.
that's my suggestion.
That's a perfectly reasonable suggestion.
Okay.
Yeah.
Okay.
All right. So after we're done this, we're going to sit and look at the room's called Ping. It's fancy. And see whether there's a time we can reserve for it.
That is also my employer. Is that a conflict? Sorry, I was making a joke. Go on.
Pardon?
Yeah.
Yes. So you're going to have to, there is a screen in that room. So you will be able to hook up to a screen, but you may have to provide your own.
Conferencing.
I-
We can,
Yeah, that,
I can-
right? I mean,
yeah.
I can make you a Google Meet if you really need it, but
oh,
Yeah, we
have
can.
options.
I'm
But
sure you
that-
have better options than I have. Yeah.
But those are all acceptable from the perspective of a design team meeting. to
Yes,
have a-
absolutely,
okay.
absolutely,
That would
absolutely.
be-
Even if you just did like link them in via one computer, it's fine. There is one of these, TV things in the room. I just have not used it, and there's no WebEx already in there,
Got
so
it.
you're going to have to bring your own.
Thank you.
Right. So we will work on scheduling this. Tiro, you're in the, but it's not a side meeting. You're right. It's a design team meeting.
Design team discussion.
So not official. All right. So Tiro, did you have something specific, or can we move on?
Yeah, I had something specific to add, right? I mean,
Okay.
Can you hear me now? Is it better?
Yes,
It's
that's better. Yes.
Yeah, thanks. So I was saying that right, from the time this draft got published, right? I mean, as an individual document to a working group document to the stage it has reached, there were various flavors, especially with regard to JWE, HPKey integrated encryption. We tried various flavors, right? And there were several. I think every meeting we were discussing what to pick with regard to encryption, whether it should move into ALG. I think this option was also being discussed. I think I quite remember at least 4 to 5 options were discussed and they were all ruled out. And then we eventually ended up at ENCIT, right? I think it's good to have a design team meeting. All right, I think many of the authors are working, attending remotely. We won't be, I don't know, if the timing doesn't work out, we won't be able to join the meeting. So it would be great if the design team meeting happens after the IETF conference so that we can all join this and we can give a summary of all the options that were considered and why they were rejected, so that acts as an input on how this draft transition through various versions, moving with the various flavors of ENC, right, from DAR to INT and some other flavors, and then we ended up here. So I think there were several sorts of discussions on that, so that would act as an input for the design team meeting.
All right. Thank you. Neil, are you online?
Yep. Yeah. Yeah. All right.
All right.
Neil Madden, I'm going to talk about the draft to deprecate alg_none and the encryption algorithm RSA 1.5. Next slide, please. So not a lot of change since last time. Had a review from Mike Jones. Thanks for that, Mike. Did most of the corrections he asked for. One of the things he suggested was adding some examples, I think, from OIDC, where good uses in inverted commas of alg = none. But a couple of people objected to that on the list, so I haven't done those so far. I don't think anyone has, apart from Mike, has asked for those to go in. So that's where we are at the moment, and the only other thing was a minor update to the latest draft of the CFRE-RG document, which deprecates and suggests workarounds for the RSA encryption algorithm. Next slide, please. So the only discussion point I saw on the list was that, as well as deprecating these algorithms, the draft adds some requirements for the designated experts to say any new algorithm registration should meet certain baseline security requirements. And there was some discussion on the list from DW and Philip around the IANA registry for Jose is also used by other standards bodies like the Web Crypto Group. And so whether these restrictions on that would prevent them registering new algorithms for JWK usage only. Next slide, please. So potentially, so this is, I think it's section 4.2 of the current document that has the wording around this. I think actually rereading it again, that it does say specifically JWE algorithms and JWS algorithms and doesn't mention JWK, so it's probably okay as it is, but it'd be useful if people have a look at that and decide. I think all of the proposed registrations for the Web Cryptography API would meet the requirements anyway. So there's a question of whether this is actually a real thing that's going to cause problems. But if it is, I'm quite happy to add a clarifying remark if people think that's a good idea, just to say this applies only to JWS and JWE usage and not for JWK usage. That's it in terms of updates. So I would love to get this into working group last call before Christmas. So
Mike?
Sure. It's Mike. Neil, thanks you for working on the draft. I said in a previous set of feedback, and then I reiterated on September 19th on the list, that the problem I have with the current text about none is it's not even-handed in its treatment of the algorithm. Particularly, the draft lists 9 ways in which none was used in an illegitimate fashion, but does not list the 2 ways that I provided where it's used in a legitimate fashion. All of those are factual. And I would request that you either list both the legitimate and the illegitimate uses, or you list none of the uses. So either delete the 9 illegitimate uses or add the 2 legitimate uses. But the current treatment of the text provides an unbalanced view of the actual situation on the ground, which I don't think is helpful to engineers building code and deploying systems. And that wasn't responded to on the list.
yeah. Were you about to say something, Karen? Or?
No, I was just going to say, go ahead.
Yeah. So I think people have responded to that on the list. And my impression was that there was no consensus around adding those, and that the consensus was rather the other way, that it's fine as it is.
2 people responded to my earlier comment. Nobody's responded to my September comment in the thread where you were requesting last call. Okay, Brian says he did. Anyway, I'm just asking for the treatment to be even-handed.
Yeah.
So people know when it's legitimate to use and when it's not legitimate to use.
Yeah. Well, I think from my point of view, the draft is deprecating those algorithms. So we're saying that they're not legitimate to use. So I'd rather we didn't confuse the.
Is there?
Okay, but that's not factual that it's not legitimate to use. You can deprecate it, but there's legitimate uses that will continue.
Is there any problem in taking out the illegitimate uses? Do you need the examples?
Sorry, I was about to raise a question to Mike about this. By the 9 illegitimate uses, do you mean the 9 references to CVEs?
Correct. That's the list of illegitimate uses of none.
That's the list
Whereas
of vulnerabilities stemming.
there's not currently any references to the legitimate uses of none.
Oh,
So the CVEs are vulnerabilities stemming from having to implement none, quite possibly because of the fact that it is part of some of the legitimate use cases.
No, I understand what they are, and it's not my preference to delete them. But the high order bit here is we should be even-handed. We should either list both the legitimate uses and the illegitimate uses, or we should list none of the uses.
Yeah, I mean, speaking for me personally, I don't agree with that assessment, but we can maybe take that to the list.
Right. My point was that despite those being quote unquote legitimate uses, their mere presence invites those CVEs.
all right. Go ahead, Brian.
Yeah, I did respond to that on list, very much agreeing with Neil's treatment of it as is, and in fact commending him for being, I think, more even-handed than maybe was necessary. I thought you did a nice job writing the text, Neil, given all the situations, and I absolutely do not think it should be expanded further towards legitimizing something that has proven to be so problematic. So.
All right. I'll follow up with the chairs. We'll do a quick, maybe a quick question on the list, and then once we get an answer on that, we will move forward. There's no reason not to move to working group last call, I believe. I believe it's ready. Other than that, there's some heads nodding. So thank you very much, Neil.
Thank you.
Okay, next is, should be Lucas. Let's see if I picked the right one. Yes, come on, Luke. Gave you a little more time this time. Oh, let me hand you the slides. I haven't done that yet.
So good morning. So this talk is about the composite signatures for Jose and Cose draft. So it was published a little bit more than 1 year ago, and it was presented already at IETF 121 and IETF 123. And it received multiple updates in the past month. So first, I will give a quick reminder of what this draft is about. So the goal is to register composite signature algorithms. So specifically MLDASA with the traditional algorithms ECDASA or EDDSA. The draft describes how to handle the composite key generation, assigning and verification. So in alignment with the LEMS composite draft, which has been submitted recently to the IESG after a successful working group last call. We also use the algorithm keeper key type, and we rely on the seed representation for MLDASA private keys in order to stay consistent with the COSE pure MLDSA draft, which is now in the RFC editor queue. And we also have security considerations and test vectors included in the draft. So since IETF 123, we have done some updates. So we now support EDDSA. We added some explanation about SUF CMA security, and we did some editorial modifications to improve clarity. We also received a lot of helpful feedback from the community. So I picked a few comments that we received here with some answers to those comments. So first, we received a comment about the lack of SUF security because of the use of the composite approach. Like in the LEMS draft, we now recommend not to use a composite if SUF CMA guarantees are required. We also received the comments about the fact that we should wait for the LAMPS or TLS composite draft before continuing with this draft. But the LAMPS composite draft has been submitted to IESG recently for publication, so I think now it's the right timing to move forward with this draft. Some also said that there is no rush to migrate to post-quantum or hybrid signatures, but as we know, large-scale deployments might take years, so starting early helps to ensure we'll have mature and deployable standards when the migration will be needed. And finally, we received also some questions about why composite signatures are relevant in the particular case of Jose and Cose. So that brings us to the next slide. So here you have some points about the relevance of composite signatures for Jose and Cose. So first, of course, that the main point of using a hybrid, it is to preserve the security of the scheme if one of the underlying signature algorithms is broken. A composite can also help to comply with some regulatory requirements. So for example, the EU Commission and some security agencies like the French National or the German national security agencies actually strongly recommend or require the use of hybrid approaches whenever possible. Also, the composite approach is quite easy to deploy among all the hybrid solutions. In particular, it can reuse some existing PKI libraries. And if you already have a deployment using composite signatures in security protocols like TLS, for example, then the same model can be leveraged. Yes, it represents a fail-safe with minimal additional cost, which is relevant for the transition period to PQC. It's relevant for Jose and Cose for long-lived credentials when you don't have the ability to upgrade, but even for short-lived signatures, because as we know, Jose stack cannot be upgraded overnight, and you have some short-lived signatures which are issued or verified by a long-lived artifact. And finally, recently, the pure MLDSA draft in Cose has been submitted to IESG, so which shows the interest to standardize solution for PQC secure signatures in Jose and Cose. And the LAMPS composite draft, as I said, is the most mature draft among other drafts which use composite at the IETF. And it has been submitted to the IESG recently. It was published in 2019 and received a lot of updates and comments. So the composite approach is not something new. And I think we can trust this approach to have a hybrid security. So the next step will be to align further with the LAMPS draft, which received some updates recently, and to add additional details about SUFCMA security. And we believe the document is in a good state to serve as a starting point for further work within Jose. And we will like to ask for a working group call for adoption.
Hi, this is Deb Cooley without a hat. So my question is not really necessarily for you per se, but for the working group. So what's the use case for signatures in Jose? Are we signing firmware? Are we signing code? Are we signing documents? Or are we doing authentication? Authentication, but not necessarily. So in some cases, you get something in advance and you keep it for some period of time and use it, right?
A very prevalent use case is like authentication tokens.
Wait, Mike, I mean, I was just going to ask you to move to the mic.
Go ahead.
Go ahead, Mike.
Mike Ellsworth. So I've been involved in various production things. If you look at OIDC, for example, OIDC is built on top of JWS. You have extremely long-lived root keys or like issuer IDP keys, right? There's long-lived keys. I think that's the target here, right?
Brian. Microphone.
OIDC is built on top of, it's built on HTTP, but it uses JWS, JWT to sign tokens that are using keys that can be rotated at the provider's discretion, and oftentimes are rotated on a fairly frequent basis. And generally speaking, the tokens that are signed and delivered to the other party live on the order of a few minutes.
All right. Well, I had an employer where keys are embedded in stuff and distributed in IoT and blah, blah, blah. Like, I think it's not always true that you can rotate all your client keys, you know, every hour, right?
Well, that's not true.
Mike.
Mike Jones, largely wearing my Kaze chair hat now, that there's certainly on the Kaze side examples where this is used for code signing in devices where keys are not going to be rotatable. Also, to Brian's point, yes, as an author of OpenID Connect, ID token signatures are going to last short periods of time. It is the case at another set of Connect specs, the OpenID Federation, that there's kind of long-lived trust infrastructure that's signed as JSON web tokens. And the key lifetimes there are a matter of choice of the deployers. So the short answer is it's all over the map.
So I will say that Jose and Jose don't have to be linked at the hip all the time, right? So if you don't use Jose for the same code signing use case that you use Jose, there's no reason for Jose to do this. If you are worried about trust infrastructures where you have roots that are long-lived, you could consider running multiple roots with multiple post-quantum algorithms in case something happens to one of them. You now have, like, you might have 3 standing, and if one of them has an attack, you can just kill it, right? And you still have 2, right? Your need for infrastructure in that case has to do with how long it takes to stand up a root, right? And get it into the trust stores. I don't know whether Jose has that problem or not. Certainly PKIX does. So in that case, you need to have the infrastructure up and running in some sense, not necessarily composite signatures, but maybe options for signatures that you then, when you actually go to deploy those things, choose one and use it. So you would not have to bear the burden of a composite signature. In my opinion, again, no hats here. In my opinion, the issue with composite anything, signatures, chems, whatever you want, is the complexity of the implementation. Not necessarily that it's hard to implement, because you technically already have one already. You have to add the combiner and you have to add the second one. The second one you would need anyway, but you also have a risk of maintenance over time. What are you going to do with dead, useless code after the quantum computer exists and you no longer need this thing that you built 20 years ago? How do you get it out of the system? Like, it's the maintenance tail on this that bothers me the most. And the fact that, I don't know, we've seen things implemented for decades. Seldom do they get it right. TLS vulnerabilities, long as your arm, right? So you can claim that it's easy to implement, but I would argue that that's not necessarily the case. So my question is, what's the use case in Jose? Not the use case in Jose, but the use case in Jose, and that you need to think carefully about how you might go about meeting that need, and it might not be composite signatures. So that's just something for you to think about, rather than just immediately jumping and doing composite signatures all over the IETF. Just because it makes sense in PKIX does not necessarily mean that it makes sense in Jose. Might make sense in Jose, might not make sense in Jose.
Well, regarding the fact that it's easy to implement, I wanted to say it's one of the easy methods among the hybrid approaches. Like, if you want to achieve hybrid security, which is strongly recommended by some agencies, then doing the composite approach might
I will suggest that you go back and look over time at implementation of crypt and how many times they've gotten it wrong and how many times they've gotten it right. And I'll postulate that more people get it wrong than get it right. And now you've made it more complex, even if only just by a little bit.
All right, John, quickly.
So I greatly sympathize with Deb's view of it. The problem is that there are things like verifiable credentials where we do see pressure from BSI especially and Europe in general for these things. I agree that in OpenID Connect, we generally encourage fast rotation of keys. So will post-quantum ever really be an issue? Don't know. Probably is a long way out. And at that point, it would be clear that doing hybrid doesn't make sense. There are some things like FIDO authentications, FIDO MDS service, where again, those are COSE algorithm identifiers, so doesn't necessarily apply to Jose, but you know, there is pressure for composite. We just now have MLDSA working off of secure elements. You know, people should probably look at ways to migrate keys when appropriate rather than or doing dual signatures if that's absolutely required. But I don't know that we're going to, if we don't acknowledge that there's a use case for these composite signatures, my fear is that people will just go around us and come up with, you know, Etsy or someone else will just define it and say, don't use Jose is the risk.
Chris?
Yeah, I think I agree with what Deb said, but my question really is, are you adding the 6 composites or is it more?
You mean the combinations?
Yeah.
Oh,
is it entire list? Or
yes, it's the entire list right now, but we can still update, delete, or add the combination afterwards. It's just,
yeah,
but right now we just have 6 combinations.
Well, yeah, I wonder if it makes sense to even minimize this list to like 1, because it's just migration. I don't know. I would minimize it then.
All right, John.
Yeah, it's John Gray. I was just going to say, I'm assuming COSE, again, I'm sort of a bit of a tourist, but I am on this draft. So when you rotate key, like I'm assuming key rotation is a thing that you do, like not key algorithm rotation. So treating these like as they're meant to be treated as black box algorithms, right? So you consider both, don't consider each component algorithm independently, consider it as one algorithm. If you already can support moving from algorithm to algorithm, you know, the maintenance of what you were talking about, it's just regular maintenance of moving from one algorithm to another algorithm. So it's not more complex from that perspective.
All right, I think for the purposes of going forward, we will, I'll consult with the chairs and we'll either do a call for adoption or we will continue this discussion prior to doing a call for adoption. It does seem like a topic that can be discussed in the context of a call for adoption. So is that okay?
Okay.
Thank you very much. Stefan? Oh, yes, please, quick. We have 3 more topics and 12 minutes.
So, okay, make this quick. This was a document I presented at last IETF. Unfortunately, in the minutes, it said that we were not ready for adoption call. While we tried to say it, we were ready for adoption call. So try to make a revisit. The big motivation of this work is that there are 2 formats for doing selective disclosures. One is STJOT, the other is MDoc. MDoc has a way to use HMAC as the key proof mechanism. STJOT allows that, but doesn't specify how it's done. And this document tries to provide that bridge. Basically, we also can do that with binded keys. I don't going to do the details of that. So let's skip that slides. It's just conclude that there is a gap between SDJOT and MDoc in that sense. What we do is we define a header that specifies how you derive the HMAC key from the confirmation key, public key that you get in SDJOT that's used for the key proof. So you have the provider public key and the recipient public key in the header. And then there is an info and salt parameters. And from that, you can derive the key based on the algorithm identified in the algorithm identifier. So since last IETF, we had another name. Now it's called the public key derived HMAC for JOES, which is better description. And the big discussion we had at last IETF, whether we should use the fully specified algorithm names or a generic algorithm names and put profiles into the header. We took the advice from the group here, and we now use the fully specified algorithm names instead. So we remove the suite parameters from the PKDH header, and we removed some options and made for default key lengths and stuff like that. The outstanding issues with this document is that open question, whether we need more algorithm profiles. This one defines one for NIST P256 curves and HKDF based on SHA-256. If we should add more, it would be very simple. The big question right now is the use of salt. The MDoc specifies a specific salt value that makes each derivation unique. It's based on a session transcript parameter that includes information about the request to do this proof. And we lack that part here, and that would make this document a little bit depending on SDJOT. Right now, it's like a generic JOES document. So there needs more discussion on the use of the salt value, also how we derive the algorithm syntax so that you can read out what it actually stands for. There needs to be IANA considerations and more examples, but if we think we're ready for a call for work group adoption for this document. And so the next step is call for adoption and complete work within JOES working group, hopefully. So there's resources where this document is currently resides. So you can see that, but I think this is the major thing here we're asking for.
All right. Any thoughts on this? And
I had a question on the authentication part. So is this, like Neil said in the chat, is this a static elliptic curve Diffie-Hellman?
Yes. And that's why the salt discussion is important, because that if you don't have a salt and you use the info as a domain tag, domain separator, then you will practically derive the same key on each document, and I don't think that's ideal.
Okay.
I wouldn't say that algorithm in itself makes a statement whether this is static or ephemeral static or ephemeral. I think it depends on the context. Context that we want to use it is in verifiable credentials like SDJOT. In this context, one of the keys is in the SDJOT. For example, if you use it for the key binding, then this is a static key because it's signed by the issuer. But the key that is used by the relying party is usually an ephemeral key. So in this context, it would be ephemeral static, in my opinion. But you could use it in other cases where it could be static or ephemeral.
You might want to be careful there, because we actually discussed this issue in context of HPKE, and there you may not if you use ephemeral mode, then you may not actually get the security properties you want, or you definitely get different security properties when combining this with an HMAC rather than encryption. So you need to be
I would agree that ephemeral is likely the most unlikely scenario. I think the likely scenario is ephemeral static or static static.
I just add that I completely agree with Paul, and sorry for saying it is static. Some use cases is static, and it could be, and so we have to tolerate that as well. But there is a lot general use case for ephemeral static too.
All right, so we're Hannes. Yeah, sorry, we need to wrap this up. Neil, 30 seconds.
Yeah, I was just going to quickly say, is it the wrong thing to be defining it in terms of Diffie-Hellman and not in terms of something like an authenticated chem, as in HBKey these days? Anyway, that can be taken to the list.
All right, we'll take it to the list, and we'll take the call to the adoption to the list.
Okay, thank you.
All right, this is the last agenda item. I need to just find.
So, Philhan Baker, I've got two drafts. I probably take both of them, I guess. DARE envelope, basically, next slide, please. So basically the idea here is it's PKCS7 CMS for Jose. And I want to use Jose to do all the specification of my signature algorithm and keys and so on, because all that mechanism's there. But I don't want to use ASN1 because my application is JS contact, which is all JSON. And I don't want to have the base 64 penalty, particularly since I often have to do multiple passes. So the approach here is, well, when I'm designing stuff inside a protocol, it's really easy because I just stick Jose headers and so on and content in blocks that are defined by the protocol. The thing that we're using at the moment, quick is the rising thing. So it makes sense to use quick variants as a way of delineating chunks of stuff to cryptography. And the envelope's just a basic, simple structure, type identifier that's also the version, unsigned header, signed header, content blobs, empty blob to ending the content, and then a trailer. Advantages here, low overhead. We are able to use all the JSON stuff inside the header and the trailer. It's efficient, one pass, serialization, you don't need to buffer. And because we're doing something new, we can use all those nice features we get from modern ciphers and signature algorithms that aren't really used in the legacy stuff. So we can use AEAD encryption because there's a block there that is to be authenticated but not encrypted. We can say always use the context string and so on. Okay, so the immediate application is for this any1 profile of JS contact so that we can make the contacts automatically update. So you exchange the contact once via QR code or whatever, and then you've got updates to that contact for life, preserving that end-to-end secure contact that you exchange it in. But it is designed as a general use construct to exchange any sort of static data. And there's a sequence version of it to do logs and whatever that I've not got time for. The URL, shall I just?
Yeah, just go ahead.
Yeah, the URL is basically another little bit of mechanism. And the goal here is to be able to locate, decrypt data by thumbprint. So the idea is I want to have a really compact URL so that I can fit a JS contact into something I can pass by QR code, near field communication, glue into an SMTP header or whatever, or use inside a JSON structure so that I can have my MLChem key reference there without putting the MLChem key there. So again, a general structure. The resolution mechanism here is fairly simple. So if this is our URL, we've got the method here. Actually, the method could be contact. It could be something more specific, which you need when you're doing QR code stuff so that the phone knows which application to hand it over to, but it's all the same mechanism underneath. So the elove wob is the multipurpose key part. And in order to get the blob of data, you put that through one digest function, splice it onto a well-known URL at the DNS authority specified in the URN, and that is how you locate the data. And then you put that same key through a different digest, the KDF, to get the decryption key IV and so on. And then you put the content that you receive through a third digest, and you use that to authenticate the content that you've received. So the idea here is it kind of cryptographically compresses data of any length to a nice short URL. And it can be used in JS Contact. We can use it to pass MLChem, MLDSA keys about without putting the whole thing into we can use it for passing images, videos, attachments, whatever. Essentially what it creates is a bearer content token for the referent content. So having the QR code is the exact same thing as having the content. And if I've got the crypto right, which is why I'm bringing it here, because I'm afraid that I might not have, not having the QR code is the same thing as not having the content, unless, of course, you can break AES-256 GCM and all the digests I'm using. And that's it. So I'm asking for a call for adoption. Did I put a slide?
Yeah.
Yes.
All right, and this went to dispatch first.
This went to dispatch, and they said to bring it here or a BOF, and so I thought I would bring it here and ask here rather than go through, you know, BOF just to be told to go here.
All right, so we are completely out of time, so we're going to have to do any discussion of these on the list.
Yeah. I'm here for the rest of the week, so if you want to talk to me in the corridors or whatever. I mean, like, there are arguments behind the choices I've made. I don't think there are any coin flips left, but if you've got something that you think should be done differently, I'm all ears. And I have made major breaking changes recently because I realized there were different ways of doing it that would be more widely applicable. So, you know, I'm a reasonable guy. This is not my way or the highway.
All right. So with that, thank you everybody for coming to today's session. We have a number of items we'll have to finish up on the mailing list that we didn't completely conclude on today. Those who are interested in attending the design team meeting, can you come to the front so we can get that scheduled? And with that, happy Wednesday.
Wednesday.
Oh, it is Wednesday, isn't it?
She wished you happy Wednesday. Oh,
have
a good Wednesday.
Oh, when we get it, when we get it scheduled, we'll put it on the mailing list.